There we go. All right, we're good to go. So we are talking about the quadratic formula today, like I said. And this is another way to solve quadratics. Yesterday when we were reviewing for our quiz, we talked about 4 methods that we've used so far, right? Talked about using a graph, factoring, square roots, and completing the square. Those are the 4 different methods we had so far. Quadratic formula might just be your favorite. I don't know. We'll see. Now this one, it only works if the quadratic is in a certain form. It has to be in standard form. Okay? So if the quadratic is given to you in a different form, maybe you don't want to use this then. But if you have a quadratic that looks like this, ax squared plus bx plus c, i.e. standard form, then the quadratic formula will work for you. Okay, so there was a mathematician back in the day. I can't tell you exactly who it is because I don't remember, but that was able to come up with a formula where you just plug in the values of a, b, and c into it, and it'll tell you where those x-intercepts are, or where those solutions are to that quadratic. Okay, and so, but it had to be in standard form to make it work. So, and here's the formula that they came up with. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, notice how in that formula you see the plus or minus and the square root. That comes directly from when we were doing the square root method. So this actually uses the square root method to get this formula, but it's right there. Also, that plus or minus ensures that you're going to have how many solutions to this thing? 2, right? You have to do the plus and you have to do the minus. Now, the only way that you might get just one solution would be if this square root of b squared minus 4ac, that whole part, ended up being what? What's the only number where it doesn't matter if it's plus or minus, it's the same thing? 0. So if this happens to come out to 0, then you only have one solution actually. Okay? Otherwise, there are going to be 2. And they could be complex. They could be just real numbers. It depends. Okay? And so we're going to investigate a little bit of how we can take a look at what's in that equation to know if we're going to have complex solutions or not, or just the one solution. Okay? So let's do a quick example of this. So let's say we have f of x equals x squared plus 3x minus 5. And so we want to find the zeros of f of x. Okay, so first things first, we have to identify the a, the b, and the c. So a is 1, b is 3, c is negative 5. So it's as easy as you think. You just take those 3 numbers, plug them in to that formula. Now, the only thing you got to be careful about is order of operations and that sort of thing. So it's all divided by 2a. So if you're going to just type it into your calculator as one big line, then you have to be careful about where you put parentheses and stuff like that. So we'll go over that here in just a minute. If it's a non-calculator type question, then it's not as big a concern because then we're just going to leave the square root as a square root. And I'll show you that. That's what we'll do for this one. So let's say we got x equals then negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 5, all divided by 2 times 1. Okay, so like I said, I just put the a, the b, and the c where they go, into there. And then now let's simplify it. Okay, so negative 3 plus or minus Square root, we've got 3 squared, that's 9. Minus 4 times 1 times negative 5. So it'd be plus 20. And then all divided by 2, right? Because 2 times 1 is 2. Okay, so this would be an acceptable way to write this answer then. Negative 3 plus or minus the square root of 29 divided by 2. So if it was a non-calculator type question and I wanted the exact answer, i.e. not a decimal approximation or anything like that, that would be your answer. Okay, and it has both solutions in there, right? Because of that little plus or minus. So one solution would be taking negative 3 and adding the square root of 29, dividing it all by 2. And then the other answer would be negative 3 subtracting the square root of 29, dividing it all by 2. So you've got your 2 solutions there either way. Okay? All right. So let's try another one where something a little different is going to happen here. So let's say we want to solve 25x squared minus 8x equals 12x minus 4. Do I need to separate you guys? Okay. So, what's the first thing I need to do here if I'm going to use the quadratic formula to do this? I'm not ready to plug in yet. You got to get the A, the B, and the C. And to be able to do that, we got to move everything over to one side, right? We've got some like terms in here. We've got some stuff on one side of the equal sign, some other stuff on the other side of the equal sign. Remember, to solve a quadratic, whatever your method, first things first, you move it all to one side equal to 0. So if we do that, I got negative 8x. If I take this 12x and subtract it over, what am I at now? Negative 20, yep. Negative 20x, and then on this negative 4, if I add that to the other side, we're at plus 4. Okay? So you had to subtract the 12x from negative 8x, giving you negative 20x, and then you had to add the 4. So that's really the quadratic we're concerned with then, is 25x squared minus 20x plus 4. Okay? So, if you were going to do, like, say, completing the square, you'd have to divide everything by 25, right? And then go from there. That's the only other method we'd have in standard form. That'd get pretty messy for this one, right? Yeah? Don't think that would be exactly the way I would want to go with it, because as soon as I start dividing by 25, yeah. So let's just take our ABC. A is 25, B is negative 20, C is 4, and let's just use the formula instead. See what we got. So for this one then, we'd have x equals negative b. Well, b is negative 20, so negative b would be positive 20, plus or minus square root of b squared. So negative 20 squared minus 4ac all over 2a. Okay. The numbers are big, but don't let that scare you. It's still very doable. So we got 20 plus or minus the square root. Negative 20 squared, 400. 4 times 25 times 4, 400. So it's 400 minus 400 under the square root then. So it ends up being 0, right? There's only one solution. Because we end up with 20 plus or minus the square root of 0 over 50. The square root of 0 is 0. And what's 20 plus or minus 0? 20. So it's just 20. It's on the top. That's it. So we got 20 over 50, and if you reduce that, what's the answer then? 2/5. Yeah. Yep. If it's a fraction, go ahead. So the answer, there's just one solution. It's 2/5. So let's think about this for a second. What does that tell us about this graph? Yeah, the vertex is going to have to be sitting right on the x-intercept then. If there's only one of them, right? So if like 2/5 is over there somewhere, then this parabola is going to have to do something like that. Okay? Sorry for those of you listening to the recording at home. You can't see that. It's on the board. But anyway. So it has to be a parabola opening up because A is positive and the vertex sitting right at 2/5. Yep. So what we just discovered was, or we kind of talked about it before, but if what's under the square root works out to 0, there's one solution, right? So I'm going to write that down here. So if b squared minus 4ac equals 0, one solution. All right, now there's two other cases to this. Okay, what if what is under the square root ends up being something positive? It's bigger than 0. That's our first example, actually. Take a look at that one. Yeah. What did we end up getting under the square root in that first example? 29, which is bigger than 0, right? And we ended up with two solutions there, right? So if we have that under the square root bit, b squared minus 4ac, if that's greater than 0, we have two solutions. Here's where things get interesting. What if that b squared minus 4ac is less than 0? There are two solutions, but what kind of solutions? Yeah, or complex, technically. And how do we know they're going to have, or how do we know they're going to involve imaginary numbers? Because where did that imaginary number stuff come from? Square roots of negatives, right? And if this stuff is less than 0, it's negative, right? Which means in the equation up here, if this is something negative, I'm taking a square root of something negative, right? I.e., you're going to see an imaginary number in there somewhere when you're done, right? So let's try one that looks like that. We're going to get some complex number stuff happening as part of our answer here. What is what? I.e.? That means, like, how do I describe that? As an example, leads to, the idea is, like, thus. It's another way of saying thus. You see this, that sort of thing. Or therefore, another way to say therefore. Okay, so here's a good one. So let's solve negative x squared plus 4x equals 13. This one's going to give us some imaginary solutions, or complex solutions. Okay, so first things first, what do I have to do? Yep, we got to get it all over to one side again. So negative x squared plus 4x minus 13. All right. Now I'm ready to go with my quadratic formula. So what's the A this time? -1. What's the B? And C. All right. So we're ready. So x equals -4 plus or minus the square root of 4 squared minus 4 times -1 times -13 all over 2 times -1. Okay. So that square root. What's 4 squared? 16. 4 times 1 times 13. 52. Positive or negative? It's -52. Okay. So I'm going to have minus 52. And then all of this divided by -2. Okay. So what is 16 minus 52? -36. Yep. Okay, class. What is the square root of -36? 6i. Right. Okay, so notice how it's divided by -2. Okay, that needs to go to each number now. Okay, because I can distribute it because I just have two numbers there. So instead of -4 plus or minus 6i, what I've actually got here, +2 Now, why did I leave that one the same? It's, somebody raise their hand and tell me. Jason? It wasn't actually already negative. It was plus or minus 6i, and I just left it plus or minus 6i.
Oh, I thought you were talking about the...
What? So it's because of the I that I didn't change it? Oh, I'm sorry. It shouldn't be a 6. It should be a 3. My bad. I'm wondering about the sign on it. My bad. That's that's wrong. That should be a 3. So my question is though, why did I not because this was -4 and I used a -2 and now it's +2 and yet it's just yeah. So 6 divided by -2 is -3, but why did I not write like a -3 in there? Yeah. It's still 2. It's still plus or minus. So really what would happen is the plus would turn into a minus and the minus would turn into a plus, which is essentially just the same thing, right? So anytime that you're dividing with a plus or minus sign like that, it doesn't really matter because it'd still be plus or minus any way you look at it, okay? So, but yeah, it should have been a 3 though. Sorry about that. Don't forget it's still distributed that way, but this still gets distributed to both of those two things. Sorry if I confused you with that. But in any event, that's your answer then. 2 plus or minus 3i. So you have your two answers, two complex answers, right? 2 plus 3i and 2 minus 3i for that. Okay? So some questions in your homework are going to have you guys just solving like this. Some are going to ask you state what kind of solutions you're going to have, okay? And that comes back to this stuff down here that we talked about, okay? Whether it's one solution, two solutions, or two complex solutions. Just so you guys are aware, this little piece, this bit of it that's under the square root has a special name. And they're going to use this term, and you need to know what it is. It's called a discriminant. Okay, so the way this goes is if the discriminant is 0, it has one real solution, If the discriminant is positive, it has two real solutions. And if the discriminant is negative, it has two complex solutions. Okay? So that's what we were getting at right there. But yeah, you need to know what the discriminant is then. Okay. I think that is all that I need to show you guys. So, all right, I'm going to let you get to your homework then.